Fine, so here we have question 8. This is also from topic 2.2 on page 72 of the one textbook that you've got. So we have a bullet of mass 0.02 kilograms is fired into a block of wood of mass 1.5 kilograms resting, this is an important word, on a horizontal table. The block moves off with an initial speed of 8 meters per second. Estimate the speed with which the bullet strikes the block. Now, whenever you've got this situation where you've got something going into something else, you have to think of conservation of momentum. So you've got the block here, it's 1.5 kilograms, and then you've got the bullet coming in. So this is the before situation. The bullet is coming in. It's got a certain velocity which you're not sure about, but it's got a mass of that is 0.02 kilograms. The velocity of this is 0 meters per second. This is the before situation because it's resting. So the velocity of that is 0.0 meters per second, and it has a mass of 1.5 kilograms. Now, with the after situation is where you have now the block, and it's got the bullet stuck into it. So we have a total mass here of the two things together. So we have a mass of 1.52 kilograms. That's of the bullet and the block, and it's got a certain velocity, and that's the one that we're going to have to find. Now, when you have this, because this is the whole system, we have this whole system and this whole system, we have no external force acting upon it other than these two things. We have the momentum before is equal to the momentum after. Now, what is the momentum before? Well, the momentum before is all given in here. Actually, sorry, we are told this. We're told that this is 8 meters per second to the negative 1. So we know that velocity. We want to work out our initial velocity of our bullet. So we've got our momentum before would be 0.02 times the velocity of the bullet. We'll call that VB to start. And that's going to equal the momentum afterwards, and that's going to be 1.52 times by 8. And so we're going to get our VB, our velocity of our bullet initially beforehand, 1.52 times 8 divided by 0.02. And we do that on our calculators. 1.52 times by 8 divided by 0.02, and we get 608 meters per second would be our speed before. Now, we are given all of these are basically two significant figures, 80, 1.5, 0.02. So we would write this in two significant figures, so that will be 610 meters per second to the negative 1 would be our final velocity of the bullet. I mean, our initial velocity of the bullet. Alright, going down, we have the bullet in question 8 is fired from a rifle of mass 2.5 kilograms. So 2.5 kilograms, assuming that the bullet leaves the barrel of the rifle with the speed calculated above. Find the recoil speed of the rifle if it is free to move. In reality, the rifle is held for a certain and for a certain person, the rifle recoils a distance of 0.12 meters. What average force does the person exert on the rifle? So we've got two things to find. I'll do them in red. Find the recoil speed of the rifle, and then we're going to find the average force. These two things we need to find. Okay, now again we've got a situation of momentum before equals the momentum after. Now, beforehand, before the bullet is fired, there is zero momentum because we are taking that the velocity of the system in relationship to itself is zero, so mv is equal to zero. Now, afterwards, we've got the momentum of the bullet plus the momentum of the rifle. And those two must add up to be zero. So obviously the momentum in one is in the opposite direction to the momentum of the other. So the momentum of the bullet is going to be 0.02. That was the mass, times by 608. I'll use the more accurate value, plus the momentum of the rifle, which is 2.5 times the velocity of the rifle. And so we're obviously going to take this over to the other side and then divide by that, and we would get our VR. So let's just calculate that. We're going to get 0.02 times 608 divided by 2.5, and we get this, the velocity of the rifle is going to be minus, to be in the negative, and that's going to be 4.9 meters per second to the negative 1. So that's the velocity of the rifle afterwards. Now, it only goes a certain distance, 0.12 meters. So obviously it deaccelerates in that time, and a force is needed to do it. But we first need to work out that deacceleration. So to work out that acceleration, we'll use this formula over here. V squared is equal to u squared plus 2as. The final velocity, it comes to a halt to 0. This would be u squared, that would be 4.9 squared, plus 2 times a is what we want to find, and s is this 0.12. 0.12. So we're going to get our a is equal to the a is equal to 4.9, so we're going to do our answer squared divided by brackets 2 times 0.12, close brackets, enter, and that would equal 98. It's actually going to be a negative because it's in the it's a deacceleration. It's going to be 98.56. We would write that as about 99 meters per second to the minus 2. Our force, obviously, force would equal mass times acceleration would equal 2.5 times the 99, and so I times by 2, and I get about 197 point something newtons, and if we do it to two significant figures, about 200 newtons. Okay, so there we have question 8 and question 9. Thank you very much.